everyone, and welcome back. We hope you enjoyed this talk from Peter around Calva. And we once again want to apologize for the quick technical difficulties we had there in the beginning. We have everything sorted now, and we're very optimistic that everything in the future will go to plan. The next talk we have is Michiel Borkent, also known as Bork Dude. And I think he almost doesn't need an introduction because he's just been so active in the community and has shipped so many things. Babashka, CLJ Condo, Jet, like all kinds of really cool tools, and tools that I believe really blend what is possible with Clojure, right? Like we've had all this like startup time things, all these discussions around it. And now there's like with GraalVM, this really interesting angle where we can build tools with Clojure that start up like in a matter of milliseconds. And today, Michiel is going to talk a little bit about that, and is going to share a bit more about his experience. And we hope you will enjoy that talk. If you have any questions during the talk, please post them to the GatherTown chat or into Slack. My moderation colleague, Stefan Kamphausen, will create a thread there where you can post questions, and we'll ask those questions during the Q&A. So without further ado, please give it up for Michiel Borkent and enjoy this talk.
Hallo, da bin ich wieder. Herzlich willkommen. I will switch to English now because my German is not so good. Welcome to my talk at clojureD 2021. It's happening again, but this time from the comfort of our homes due to the COVID pandemic. So today I will do a talk about how to create your own Clojure CLI binary using GraalVM native image. And so we all know tools like JQ, but we are Clojure programmers and we know better than to create some DSL that you have to learn. If you already know Clojure, know Clojure, why would you create a new DSL? That's a waste of time. So I will show in this talk how to make your own JQ improvement, and this JQ improvement is called JFoo. It stands for JSON function, because we want functions. We just want to write Clojure functions. That's the idea. But we want to have them on the command line. Okay, so in the Clojure ecosystem, we already have tools like Babashka, which is a fast Clojure scripting runtime. But I can imagine that you would like to create your own tools because that's just a nice thing to be able to do. So we have Babashka, and there is also a tool called Jet, which allows you to transform Eden into JSON and vice versa. So this JFoo tool that I will teach you how to make is very similar to Jet, but Jet is not set up as a tutorial, and JFoo is set up like a tutorial. So we have basically 3 steps that we need to do. The first step is let's create just a Clojure program that that does things that that behaves the way we want. So for this, I will use tools CLI in a new Clojure project. So let's just create a Clojure project from start. So I go into the temp directory, and then I type JFoo, and then I will create a deps Eden. Okay, deps Eden, yeah. Deps, so we need tools CLI. Tools CLI Maven version, what is it? 1.0206, that's the newest. Okay, so there I have it. And then I will create, oh yeah, for GraalVM, it's always recommended to use Clojure 1.10.3 because that contains some fixes for specifically for GraalVM. So always use this one or the newer one. That's my recommendation. Let's see. Yeah, okay, and we also need something around JSON. So just let's pick Clojure data JSON. And what version is this? Clojure data JSON. That is 2.3.0. Maven version. Oh, 2.3.0. Okay, so this is our basic dependency setup. This is all we need to create our nice JFoo CLI. So what JFoo should do is we pipe some JSON into it, and we give it a function to transform the JSON, and we also can give it a keyword function to transform the keys. Okay, so let's see. Okay, so we will create source and then jfoo main.clj. Okay. Let's see, jfoo main. Okay, main. And we will require this named Clojure data JSON as JSON and Clojure tools CLI as CLI. Okay, and then we need to create a main function which has some arguments, and we need to parse the arguments, and then we have to make up some format. So what do we want to parse? We want an F argument and a K argument. So parse. What does the library recommend here? Let's see. CLI options. Def CLI options. We want F, and we call it func, and it's a function, something like this. The function applied to the JSON from standard in, or something. So we parse our arguments using this tool CLI, and let's just print it. Let's see if that already works a little bit. jfoo main foo. Let's see what it prints. That doesn't work. jfoo main. Why doesn't this work? Why? Let's see. Yeah, I made a typo in the file name of this file. There was a typo here. So now let's see if this works. Yeah, that works. Okay, so we parsed the function foo. That's all right. Okay, let's do it like that. We have the parsed options, and now we have the options parse. All right, so print opts. Let's test it again. Yep, func foo. Okay, that's all right. So, and now we want to transform the JSON from standard in. So let's fetch the JSON from standard in. I think that is JSON read, and then you can just do this. Let's also print the JSON. So I will read it from standard in. So the star in star, that's the standard in reader, and you can just pass it to JSON read. Okay. So let's echo some JSON into this. Okay, so this works. We have got the JSON from standard in, but it's nice to be able to transform the keys using keywords. So that's the key fun argument. That works. Yeah, that works. And we have to apply the function that we put here. So let's just make it a keyword for now. So you see, we have this function, but we have to parse it or evaluate it somehow. And Clojure has a nice thing called load string that you can use to evaluate strings to Clojure expressions. So let's do that. Func opts, and now we load string it. So we have evaluated this function. So now, and we will do the same with the key fun. K is, okay, let's add it here. Basically the same, but for K. Key fun. The function applied to the JSON keys. Yeah, okay. This is all right. So key fun opts, and we also have to load string that beast, load string K, and now we can apply F to the JSON. Oh yeah, so we first need this keyword function here, and we need to pass it to the JSON parser. And now we have function F, and we apply it to the JSON. Let's see. Oh, there is a null pointer. What is the matter? I think I made a typo somewhere, maybe. So either the key fun might be nil, or I'll just print it to debug it. Let's see, nil. So the key fun is nil. Yeah, that's true, because I didn't provide the key fun here on the command line. So so I think we need some default, or if K, then we load string it, and else it's identity or something. Yeah, and maybe the same with or if F. So, and else we do the same with F. So we default to identity, and you can clean up this code maybe later. But oh yeah, and of course we have to print it. So we do prn. So we print the Eden as a side effect. So, oh, it's nil. Oh yeah, and it is nil because I didn't provide the key fun. So I provide the key fun as well. So now, just once again, so you see that I pass some JSON, and I evaluate this function, and I evaluate this function and apply it to the JSON, and then I get this. So now our basic CLI works. Let's see. So that is basically part one. Yeah, we can make this nicer to add a help to this CLI, but I think you can figure that one out on your own. what we will do now is proceed towards the native image compilation. So what we have to do in order to accomplish native image compilation is transform this Clojure code into bytecode. That is the job of the Clojure compiler. And somehow give the native image this bytecode. So GraalVM native image is a tool. It's a JVM implementation, which comes with a tool called native image. It has more tools, but that's the thing we are focusing on right now. Compile applications into small self-contained native binaries, okay? So what we need to do is download it, but I've already downloaded it. GraalVM I have it here. So I downloaded GraalVM to my downloads folder, and it's in it's just here, so I can open it and show you. I just downloaded it and unzipped it. That's all I did. There is no further installation needed for this tutorial. So what I did do is export GraalVM to this directory, and that's it. And the rest is, the rest, I only need to set this environment variable, and then my scripts that I will show you will pick up on this. But before we use GraalVM, we first need to create an ubijar. Compile it and make an ubijar. I think that is the easiest way. So what I always use for creating ubijars is a tool called depstar, deps Eden, and so I will create an aliases, and so with an ubijar alias, and I use the depstar tool, and this creates a jar called jfoo.jar, and the main class is jfoo main, and I say AOT true, then Clojure will emit the bytecode to disk. So I can now do this ubijar or x ubijar. This will fail. Why? Because, well, it will maybe succeed, but we cannot run the jar. And why is this? Because you need to do one extra thing. So if I do this, oops. So I should now be able to run this the same way. But we need to also add one thing to our main, which is called gen class, which creates a main class for this namespace. So we do it one more time, and then it should work. Yeah, okay, it worked. So we are ready to do some native image compilation. Before that, I will introduce you to a new feature in Babeshka, because we will use Babeshka for the scripting part of this project. So we don't have to write any bash scripts, which has the benefit that it also will work on Windows and other operating systems of the future. So what this does is, so here we see the ubijar command that I already showed you in the command line. So we just do Clojure x ubijar. It has an optimization here that looks to the source folder if there are any newer files compared to this jfoo.jar file, and if not, it will just completely skip this step, which makes it a little bit faster. So I can now do bbubijar, and it's done immediately. But when I touch something in the source folder, then it will run the ubijar compilation, because now it needs to refresh the ubijar. So that is the ubijar task. So Babeshka has a task runner, and you can just say bbubijar, and then it will execute this part. Okay, so if we want to run the ubijar using Babeshka, we just invoke java-jar jfoo and then pass any other command line arguments. But this depends on the ubijar. So when we do like this, bb run uber, and the ubijar was not there, or some source has changed, then it will first recompile the ubijar, and then it will run the program. So this is kind of a replacement for make, but now is the interesting part. So we have the native image step, which is what this tutorial is all about, right? So we depend on the ubijar to be there, and if the ubijar is there, we will invoke the GraalVM tool called nativeimage. And this nativeimage tool, well, this depends on the GraalVM environment variable to be set. So if you don't set it, this task will crash. So we could have better error messages, etc., etc. But for this talk, I will just keep it to the basics. So there are a couple of settings that you will always need in Clojure projects, which is the one important thing is initialize at build time. So we can what GraalVM will do is classes have static initializer blocks, and it will initialize those at build time instead of at runtime. And with Clojure we cannot get around this. So it's a little bit of a detail, but you just need this. Just if you do Clojure projects with GraalVM, just use this. And here we say, oh, here you have a jar with a main in it. Just compile it to a native image. And the name of our binary will be jfoo. And these are some sane settings. We don't want a fallback image, which is basically a full JVM in a jar, or in a native image, which we do not want this, and we do not want some native image server in the background. We just want to start from scratch. So these are the basic options that you will always need. So let's try it out. bb native image. Okay, the compilation ran, but what happened? Something went wrong. It says unsupported method class loader is reachable. What GraalVM version do I have? GraalVM home. It's 21. Okay, this is not the newest. Let's switch to another one. Maybe that helps, right? GraalVM home, and I will put it to, I have one newer one. So let's just try it with that. I will run bb native image again. So this time it worked, no errors, and we have a binary called jfoo now. It's 34 megabytes. Let's try it out. Echo. So instead of run uber, I say my jfoo thing, and it worked. Whoa, nice. So if I don't apply a function, I get identity. So it's the entire JSON, and you see it's very fast as well. So this is awesome. It worked. I don't apply any keys or functions. Well, yeah, it's the raw JSON. It seems everything works, right? But what if we apply a more sophisticated function and more sophisticated JSON? So let's see, we make another level in this thing B1. Yeah. Let's see. Okay. Yeah, that's true. So, but now we want to go 2 levels deep. So we need to have something like a function of the JSON, then go JSON AB, right? Something like this. Let's try this. Oh, what is this? It says exception macro expanding caused by not something with spec. So it tries to do some macro spec checking. So let's disable that in the native image. Okay. So now it gets interesting. I will pass this Clojure system property to the JVM that is generating the native image. So it will not do this spec checking at in the image because that actually fails, but you don't see the reason why it fails. So I have compiled native image again using this setting, and when I repeat this jfoo invocation again, then we see the real problem. So there is a syntax error compiling function, which is not actually a syntax error, but the problem is that native image cannot define classes from new bytecode at runtime. So this is a problem that we have with loadstring. Loadstring is actually compiling new classes and emitting bytecode for these classes. And this is a limitation of native image. So in native image, you cannot generate new classes anymore because it's basically a closed world of your entire program. And you don't have a JVM anymore to do more. So what now we need to make some workaround for loadstring. We cannot use loadstring. You cannot also not use eval. Because loadstring is basically parse plus eval, and eval is where the real problem is. So now there is one solution, which is called the small Clojure interpreter, and this thing doesn't emit bytecode, but it evaluates Clojure in an interpreter, and this interpreter is written to be compatible with GraalVM. So you can use it as a replacement for loadstring. So let's try that. Okay. So I'm adding SCI to the depth Eden here, and the small Clojure interpreter it stands for. And now we will require it over here. Borkdude, no, not Borkdude, SCI.core as SCI, and instead of load string, we do eval string from SCI, eval string, and now we do here eval string. Let's try, let's redo the compilation, bb native image. It will make another ubijar first, and then it will compile. Let's see how this compiles. So the compilation is done again. Let's see, ls jfoo. And what we also see, if we don't use load string, but we use SCI, the image doesn't become bigger, it becomes even smaller, almost 10 megabytes or more than 10 megabytes smaller. So let's see if it now works. Okay, so now we can evaluate this function on the command line, and we can make some weird keyword function as well, I guess. Let's do a function, and then we just append the key twice. Let's see what that does, if that also works. Okay, so now we have duplicated the string key twice. So this brings a lot of flexibility to the command line tooling, and it's very fast as well. So this isn't entirely fair. Oh yeah, it is. So here you see the time it took is only 20 milliseconds. So it's basically nothing. On Linux, it's even faster because details. But on Linux, it's only 3 or 4 milliseconds. So now you see we have created a very cool CLI which replaces JQ in some ways, using normal Clojure functions on the command line, and all we needed to tweak to our normal Clojure program is, instead of using eval or load string, we use the small Clojure interpreter, which is a small price to pay, I guess, for command line tooling. And you see that your command line tool didn't become bigger because of Psy, but it even became smaller. And the reason for this is that load string pulls in a lot of tooling from the compiler, and if you use this, then the GraalVM static analyzer will think you will need this at runtime. So it will include all of this in the native image. And if you don't use that, it leaves it out. And the small Clojure interpreter is quite small. It's optimized to be used in GraalVM, and that is why we get a reasonable size image now. So if you want to know more, these are just the beginnings of native image, about how this works. And the 2 main websites I recommend if you want to know more is CLI Graal docs. So this contains a lot of nitty-gritty about some corner cases that you can run into when you make GraalVM binaries. So it has some tips and tricks using a Clojure version, what you should use, some tips and tricks around reflection, etc., etc. So if you want to continue on this road, I suggest you take a look over here. And then there is another cool repository by Bruno Bonacci, which lists a lot of compatible Clojure libraries that are compatible out of the box with GraalVM native image, because not all libraries are out of the box compatible, but with a little bit of effort they can be made compatible. For example, if they use eval or something, you have to apply the trick that I showed in this talk. But a lot of libraries don't use eval, and a lot of libraries are already out of the box compatible. So these are the 2 websites I would go to: GraalVM Clojure, and the other one was CLI Graal docs. And of course, if you want to revisit what I did in the talk, you can visit this Borkent JFoo repository. I will add more text to this repository in the future, and I will also add the link to this talk, so you have some nice place to go to start reading if you want to start from scratch. So I hope you liked this talk. We're coming up on 33 minutes, so I will round it up now. It was a pleasure to do a talk at clojureD again. It's my favorite European Clojure conference, one of the, because, oh man, there are, we also have clojureD, that's also my favorite. My God. I wish we can just meet each other again next year in real life after the pandemic. And until then, stay strong, keep doing Clojure, and see you in the Q&A maybe on this conference. Okay, see you later.
Okay.
Hello, Michiel, and we're live. Thank you so much for the talk. I hope everyone enjoyed that and get to see some of your amazing live coding skills. definitely, yeah, impressive to just chug it out like that and do so much in so little time. We have a few questions from the chat that we can go through. And one of the first ones was kind of around the distinction between, okay, when do you use like GraalVM and SCI and so on versus Babashka? I guess like GraalVM is kind of like the lower level thing where you can maybe do a little bit more, but maybe you can kind of like explain how you choose between those tools, because you've obviously written tools kind of more on top of Babashka and like plenty of tools on top of Graal, including Babashka.
Yeah. So Babashka is easier to use because you can just run your code immediately. And so for everyday scripting, I would just go with Babashka. Unless you are using libraries in your project that Babashka either doesn't have built in or cannot run from source, because Babashka is built using SCI, the interpreter, and the interpreter is not as powerful as Clojure, the full Clojure language. Some things are not supported, like def type, for example. So if your library has some def type then maybe Babashka cannot run it, and but for most everyday scripts, maybe this isn't the problem. But if you have a larger application, then and you would like to make a native utility out of it, then you can go with GraalVM. But obviously, this requires more setup. Like I showed in the video, it requires more investment to get it running.
Yeah, that makes sense. It's I've been using Babashka a little bit, and I think it's still like impressive how much it does. Like I actually have done a lot of kind of Babashka playing around and like never hit that limit of like, okay, this is the part of Clojure that is not implemented, right? That is not supported. And like it's amazing how far you can get, and even how many libraries just work with that, right? Just because they don't use some of these tools. And like I think, as my understanding is that it's like class loaders is kind of one thing, and like def type and this kind of stuff. So there's really, I guess if you author your library in a certain way, you can definitely like target both.
If you write pure Clojure functions and you do not use any low-level constructs like def type, and you do not use any custom Java classes like from third parties, then it's likely that it will run with Babashka.
That's very cool. So one other thing that people noted in the chat was that your GraalVM compilation ran so fast. Did you edit that in the video, or did you?
I edited that out a little bit because else the video would become too boring. But it usually takes for a small project like in video, it takes maybe around half a minute to a minute to compile. So.
Okay. But so for this project, it would have been like 30 seconds, 60 seconds, something in that range for the Jaifu thing. Yeah. I mean, that's still like, it's still pretty fast.
And you can develop your projects just using a Clojure REPL, and when you're done, then you will compile it to native image. So it's not like you have this feedback cycle of 1 minute every time.
Right. Yeah, that makes perfect sense. I just saw a fun question in the chat that is very new, but I like it, and it kind of ties into this whole like you're doing so much in the Clojure community, and that person in particular is describing you as in quotes the Batman of the Clojure community, and he's kind of asking, how do you make it stay for fun as opposed to letting it transform into a chore? And I think I also wanted to ask a question around that, and maybe you can touch on that as well, which is like how, like, I think some people do open source for a living. And I think from what I'm seeing, like all the stuff you're outputting, like I would it would seem very deserved for you to be able to live from that, if that makes sense. And I would be curious if you kind of thought about that, or if you're, where you head in that space.
Yeah. So to combine the questions, I like very much still working on these projects even after 2 years, because I don't know. Just making tools around Clojure is, for me, it's very much fun.
Yeah.
And also to enable Clojure in new ways on the command line, and to bring some stuff to editors to help people create Clojure programs.
CLJ Condo.
Sorry?
CLJ Condo.
Yeah.
I'm using that every day.
So for me, it's just very rewarding to see that it's useful for people. So, and that's also the fun for me.
Yeah.
And I would like to be able to sustain myself from this. But currently, there are some companies who are giving very significant amounts. But if I count it all up, it's not like full income yet for me. So it's not possible for me yet to quit my job and to do this full time.
Yeah.
So right now it's mostly on the weekends, and I work 4 days at my main job. So I have 1 weekday as well. So let's say 3 days a week I can spend whenever I want the time on it.
Yeah.
And I can also prioritize the issues that I work on based on how much I want to work on it myself. So that's where I keep the balance between fun and chores.
That's cool. And if I guess if people wanted to support you and kind of making that sustainable as a like full-time activity or whatever, that's my timer. Where should they go? What is GitHub sponsors your the best channel, or?
So the main two things are GitHub sponsors and Open Collective. So these are the two main options that you can use to sponsor me.
That's awesome. I really like that. I really wish there would be more of that, and I'm really happy to see all the amazing work you've done for the Clojure community. So thank you very much for that, and thank you so much for your talk. And I think with that, we're going to give it back to Sandra and the rest of the studio here. And we're going to do a little break, and there's going to be some fun entertainment going on. And the next talk is going to start at 1:15 Berlin time. So that is in half an hour. Cool. Well, Michiel, thank you so much. It's been a pleasure to have you, even though we haven't been able to meet in person and maybe have a beer or something. Next year, exactly. I'm looking forward to that. And I hope you enjoy the rest of the conference as well.
Thank you so much.
Thank you so much, Michiel.